I'm Carly Witter, and this is Communication 101, my process speech. Today I'd like to talk briefly about a subject that we could talk for days on end about, antibiotics. Antibiotics are familiar and common to our society today, but do we really know how they work to keep us healthy? Antibiotics are derived from other microorganisms, and they work to fight bacterial infections. The word antibiotic comes from the Greek anti meaning against and bios meaning life. We know they don't work against human life. We would be in a lot of trouble without them. However, they do work against live bacteria. The first discovered antibiotic and the most well-known is penicillin. Penicillin comes from a mold and works against a variety of bacteria today. Antibiotics work in one of two ways, as either a bactericidal agent or a bacteriostatic agent. Bactericidal agents are helpful when a bacterial infection in the human body is too much for the immune system to handle on its own. Bactericidal agents immediately kill the bacteria that they come in contact with. There are two ways in which bactericidal antibiotics work. The first way is to inhibit the synthesis of the cell wall in the bacteria. The cell wall is a very important structure in the bacteria. It holds the bacteria together, it protects it, kind of like its outer shell. When the synthesis of the cell wall is inhibited, the bacteria is deformed, it can't function properly, and it also ruptures easily. This leads to the cell death. It is basically a non-functional cell. Examples of antibiotics that work this way are penicillins, bacitracin, and vancomycin. A second way bactericidal antibiotics work to kill bacteria are to cause the cell membrane to function improperly. The cell membrane is a membrane behind the cell wall. It's important for many processes within the cell. The most important process that it is in charge of is the permeability of the cell. It lets things into the cell, it pumps things out of the cell, it controls the equilibrium inside the cell. When the cell membrane cannot function properly, essentially what happens are fluids enter the cell and the cell cannot pump them back out. The cell fills, bursts, and dies. Examples of antibiotics that work against the cell membrane are called polymyxins. Sometimes it's not necessary for an antibiotic to kill the bacteria it comes in contact with. Sometimes it only needs to slow the bacteria down so the human immune system can catch up with the bacteria and take care of itself. There are certain antibiotics called bacteriostatic antibiotics that do simply this. They do not kill the bacteria that already exist, they keep them from multiplying. Erythromycins and tetracyclines are examples of bacteriostatic antibiotics. They inhibit protein synthesis in the cell. When the cell cannot produce proteins, basically all cellular functions cease. It becomes a non-functional bacterium, and the immune system can then take over. Sulfonamides are a second kind of bacteriostatic antibiotic, and they work by inhibiting nucleic acid synthesis. In other words, the cell cannot produce any more DNA. If a cell can't produce DNA, it can't multiply, there can be no new bacterial growth. The choice of antibiotics used are based on a multitude of clinical factors, and there are times when bacteriostatic and bactericidal antibiotics are used in combination. Of course, the doctors have to be very careful when they're prescribing these combinations to make sure the drugs will work well together. Resistance is another problem that comes into play using antibiotics. Bacteria are highly adaptable to their environment. They mutate very easily. These mutations can lead to new strains of bacteria. Sometimes a new strain of bacteria will contain a mutation that is very beneficial for their survival. There have been new strains of bacteria found that can defend themselves quite well against antibiotics. Some have been found that produce enzymes that actually destroy the antibiotic that is specific to them. Others have been found with mutations that change their permeability. The cell is actually able to block the antibiotic from entering. Another way that they have mutated, they've developed altered structures, pathways, and enzymes that block the processes that the antibiotics use to fight against them. Antibiotic resistance is a reality and a threat today, and misuse and abuse of the antibiotics are reasons why physicians today sometimes won't hand you a prescription for an antibiotic unless they think that you really need it to get well. The processes by which antibiotics work to keep us healthy are highly complex, and this has been a very basic explanation of these processes, but hopefully you will come away from this with new knowledge and appreciation for these bacteriostatic and bactericidal antibiotics. Thank you.